Okay, so we're going to go over significant figures. Significant figures, the first thing we're going to do is we're going to determine the number of significant figures in any figure or any number, and then I'll explain why these are important for us. So the first question we're going to answer is, how do you determine the number of significant figures? And so each number has a Pacific and Atlantic side. What I mean by that is, if you think of a map of the U.S., you have the Pacific Ocean and you have the Atlantic Ocean. And so each number has, if we take this example, has a Pacific and Atlantic side. All right, so let's go ahead and read the first rule to determine the number of sig figs. It says, if the decimal is present, start counting from the left side of the Pacific number, which is, we call the Pacific side, starting from the first non-zero digit. A couple things to notice. The reason why we talk about the Pacific and Atlantic is because Pacific starts with a P and present starts with a P. And then the second thing that's important is non-zero digit. Okay? So the non-zero digit helps us to start counting the number of sig figs. So let's just do an example. So here we have 0.2. I have a decimals present, and so I'm going to start from the Pacific side. So present, starting from the Pacific side. And I'm going to start from the first non-zero digit. So if I start from this side, the first number I run into is a 0. Now that 0 is not significant. Why? Because you start counting from the first non-zero. So this is a 0, and so it doesn't count. The first significant figure I have is a 2. 2 is not a 0, and so I only have one significant figure. The second example, here I have my Pacific and Atlantic side. Here the decimal is present, so I start counting from the Pacific side. My first number I encounter is a 0. I can't start with a 0. It has to be a non-zero, so that's not significant. The next number is a 2. That will be significant. It's not a 0. And then the number after that, once I start counting, so like once I run into a non-zero, then I will start counting. It doesn't matter if it's a 0. So that wasn't very clear. So I have the 2. And then once I start counting with a non-zero, it doesn't matter if the next number is a 0. Yeah, it will be significant. So this 2 and the following 0 is significant. Sorry about that. So let's do the next one. So I have Pacific, Atlantic, and let's take a look at this one. Actually, why don't you try it on your own, and then you press pause, and then I'll go over it. So here are the decimals present. I'm going to start from the Pacific side. I'm going to start from the first non-zero. So this does not count. This doesn't count. I found my first non-zero. Then I start counting, and I blindly count, ignore, and there's going to be 4. So even though there's zeros after the 2, I still count them. Once I start counting, I don't care if there's zeros or not, right? And so here I have 4. So I should have just 2, 1, 2, and 4 number of sig figs. All right, moving on. Okay, what about the opposite case? If it's Atlantic, you start counting from the Atlantic side, starting from the first non-zero. So here's your Pacific, here's your Atlantic. Here I see there's no zeros, right? Or sorry, no decimals. The decimal is absent, so I'm going to start from the Atlantic side. Both begin with A, right? And so this 0, I don't count. This 2 is my first significant figure, and so this one has 1. Pacific, Atlantic. 0 is not present. Start from the Atlantic side. I got 1, 2, 3. The 2 is my first non-zero, and then the 0 and the 2 are also significant because they follow the 2. All right, and then let's take a look at the last one. Here, the decimal is absent, and so I start from the Atlantic side. However, this first number that I encounter, right, is a 0, so it is not significant. The first non-zero I get is this 2, and then I start counting irregardless if it's a 0 or not. So here, this also has 3 significant figures. Okay? All right, so let's do some practice together. So my suggestion is when I get to the next slide, go ahead and try all of them, and then I'll go over the answers with you. So you're going to have to press pause. And I'll go ahead and show you each one. All right, go ahead and try it, and I'll go over the answers. All right, so 1,000 kilogram, the decimal's absent. I'll start from the Atlantic side, start counting this way. No, no, no. Those are all zeros. This has one sig fig. Here the decimal is present. Start from the Pacific side. That's my first significant figure. I'm going to start counting 1, 2, 3, 4. So it has 1, 2, 3, 4, 5. This has 5 sig figs. Here the decimal is present. Start counting from the Pacific side. Nope, nope. Oh, there's my first sig fig. I'm going to start counting. 1, 2, 3, 4, 5. That has 5 sig figs. Decimal absent. Start from the Atlantic side. This 0 is 0, so it doesn't count. Oh, there's my first one. Now I start counting, even if it's a 0. So I got 1, 2, 3, 4. And then this one's a little tricky. This is scientific notation. The reason why I brought it up is we just care about that number. Okay, this just tells us the number of what to multiply by. But this number to the left of the multiplication sign is the one that determines our sig fig. 1.0. Decimal's present. Start counting from the Pacific side. The first number is a 1, and then I start counting because it's a non-zero. This should have 2 sig figs. All right. Why is this important? Significant figures are important because it helps determine the precision of measurement. Let me give you an example. So let's say somebody said, hey, I measured it and it was 10 centimeters, and so another person said, hey, I measured it but it was 10.0 centimeters. In your math class, that's the same number, it's 10. However, in science, it's different. This guy is saying he has only one significant figure, right? Decimal's absent. Here the decimal's present, so this person has 3 significant figures. What they're saying is, hey, I can measure with an accuracy up to 3 sig figs. I can only measure an accuracy of 1 sig fig. So this person is saying that they have a more precise measurement. So this has a more precise measurement. They're saying they can measure, or their ruler can measure all the way to 1/10 of a centimeter. Whereas this person's saying, I can measure to the tens place of a centimeter. So their ruler only goes to a tens of a centimeter. The ruler can only show 10, 20, 30, 40 centimeters at each notch, whereas this can go 0.1 centimeters, 0.2 centimeters. So then we know that it's not that it's more reliable, it's just more precise, right? And so it's almost a way for scientists to communicate with each other without having to write, hey, my ruler or this measurement goes to 1/10 of a centimeter. We just write the sig figs in a certain way. It's like a hidden language almost. And so it's our way of communicating with each other, as nerdy as that sounds. All right. The biggest thing after this lesson is, are you able to determine the number of sig figs? And so click on this tutorial. And what it does, it's really neat. It's a random number generator, and you just click on new problem, and then so here you see how many sig figs in 664290. And the best way to learn this is just to practice, and you'd be surprised after 5-10 minutes how quickly you'll pick up. But let's just do this one together. This number has no decimal, so I'm going to start counting from the Atlantic side. That 0 doesn't count, right? So I'm going to count from the right side. I'm going to ignore that 0. And then these are significant. 1, 2, 3, 4, 5. I'll put my answer here. 5. Check my answer. We got it correct. And then you can pick a new problem. And I would just keep on going. Okay? Hope this helps.